Assalamualaikum and good morning. We are students from Applied Science AS120. My name is Nurshaza Huaida binti Hazizul with my teammate Nur Farjina binti Zulkifli. And today we will be presenting about spectroscopy and flame test principle. This presentation will cover the relating electron transition to emission spectrum and color. Let's begin.
First of all, let me introduce to you what is spectroscopy. Spectroscopy is an instrumental method that resolves the blended color into a unit line spectrum for precise identification and quantification, especially for complex samples. What about the film test? The film test is a simple chemistry technique to identify metal ions by heating a sample in a flame.
The basic flame test might be used as an inexpensive and quick preliminary screening method to get an initial indication of which metal ions are present based on the characteristic color produced in a flame. Spectroscopy can be used to confirm which elements are present and detect impurities by analyzing the emitted spectrum for accurate, reliable, and quantitative analysis. More advanced spectroscopic instrumental methods such as flame atomic absorption spectroscopy or flame emission spectroscopy used. Have you ever wondered how they work together? Heat from a flame or a more energetic source excite the electron in the metal atom to a higher energy level. As they unstable, excited electrons return to their original lower energy states. They emit the absorbed energy as light of specific characteristic wavelength. We can also see in the other applications such as astronomy, environmental science, forensic science, and material science. In astronomy, we get to identify the elements in stars using emission of spectra. In environmental science, we get to detect metal pollutants in water or soil. For forensic science, we can analyze trace elements in crime sample. And for material science, we can characterize metal alloy and ceramic.
The next one is principle of spectroscopy. Spectroscopy is a technique used to study how light interacts with matter. It helps us identify elements based on the light they emit or absorb. A film test is a simple example of atomic emission spectroscopy, where we observe the color produced by elements in a flame. The principle behind this is that electrons in atoms occupy fixed energy levels, and the light we see from the electron moving between themselves. What about the principle of the film test? The principle of the film test is based on electron excitation. When a metal ion is heated in a flame, the electrons absorb energy and become excited, causing them to move higher, unstable energy levels. These excited electrons then quickly return to their original energy levels, releasing the absorbed energy in the form of light. Each element has a unique energy gap, so the emitted light has a specific wavelength and produces a characteristic flame color. For example, copper gives a blue-green flame, while lithium produces a red flame. So, this is the usual flame color for each of these elements. For the element lithium, the flame color is usually red. For sodium, the flame color is strong, persistent orange. For potassium, the flame color is lilac or pink. For rubidium, it's red or red-violet. The flame color for cesium is usually blue-violet. For the calcium, the flame color is orange-red. Meanwhile, for strontium, the film color is red, and for barium, the film color is pale green. For copper, it was blue-green, often with white flashes. And lastly, for lead, it was gray-white.
Now, let's explore the electron excitation and emissions. Electron is an atom normally stay in their lowest energy level, called the ground state. When we add energy, such as heating a metal salt in a flame, the electron absorbs this energy and jumps to a higher energy level and become excited. These electrons are unstable, so they soon fall back, releasing energy as light. The color of this light depends on the energy difference between levels. For instance, sodium emits yellow light because of the specific energy gap in its electrons. For the application, initial screening using a flame test. A small amount of a powder is placed on a clean nichrome or platinum wire loop and heated in a hot, non-luminous Bunsen burner flame. The powder produces a very instant bright yellow or orange flame color, which persists and can mask other potential color. This instant yellow color is characteristic of sodium ions. These rapid, low-gas tests provide a preliminary indication of a sodium compound, for example, table salt or another sodium salt.
The next one, a detailed confirmation, is carried out using spectroscopy. To confirm the presence of sodium and to detect any other trace element, advanced techniques such as film atomic absorption spectroscopy or film emission spectroscopy are used. During this process, light from the flame passes through a spectrophotometer, which separates the light into different wavelengths and measures their intensities. The results shows distinct characteristic emission lines at specific wavelengths. This confirms the presence of sodium and also allows the concentration of sodium in the sample to be determined. Film test has a weak color and it interferes from mixture. Meanwhile, spectroscopy is expensive and it requires a trained personnel. The figure here is the example of the film test color and bright line emission spectra for metal chloride.
The figures show flame test colors and bright line emission spectra for metal chloride. Here we got lithium chloride that turned into orange red, sodium chloride turned into yellow, potassium chloride turned into violet, calcium chloride turned into yellow orange, strontium chloride turned into red, and copper 2 chloride turned into green.
In conclusion, spectroscopy and film tests are based on the basic idea that electrons can be excited and then released. When this happens, they absorb energy, move to higher energy level, and then release light when they return to lower levels. The light that is emitted has color and emission spectra that are unique to each element. This makes it possible to tell what a substance is. Film tests provide a simple and rapid qualitative method for detecting metal ions, while spectroscopy offers a more precise and reliable analysis by measuring exact wavelength. Together, these two techniques are essential tools in chemistry with important application in laboratories, industry, and scientific research. That's all for our presentation. Thank you.